Hello, this is just a little video more for myself, just documenting my journey in creating my own remote controlled robot. What my hope in the end is to have a basic wheeled robot, a little robot car so to speak, that will move around based on commands from a joystick remotely. And for that I'm going to use a few different components. It's going to be controlled with the Arduino Uno microcontroller, which I happen to have here already on the chassis. As a motor controller, I'm going to use the L298N. The couple of 6-volt motors, so a little caster on the back, a number of wires, a power source, a couple of power sources. And I'm going to go through in detail a little bit about what I did here and why. Again, this is more for myself. I don't know if everything I say is going to be completely accurate or correct, but I figure I would document what I'm doing here, and hopefully maybe someone else out there can benefit from it. So what I did first is I measured out what I was going to need, my components. And I wanted to make a chassis out of plexiglass, which I have right here, and this was the original plan for it. I just kind of mapped it out on paper where everything was going to go: the motor controller, the main controller, the power source, another power source, the wheels, the back caster, and I cut a piece of plexiglass. Now the motors themselves are 6-volt motors. There's 2 of them, only need 2. For this particular car, and I've hooked up brown and orange wires. First I figured out what makes the motors go forward and then backward, and hooked up the wires in that manner just by using a 6-volt battery and touching the connections. I could figure out this goes forward and this goes backward, because these don't really have positive or negative marks on them to tell you where to put the. I'm sure there's a way to tell, or there's a standard for it, but I didn't know, so that's what I did. Now I soldered the wires, an orange and a brown, and then orange and a brown over here. And what I did was, to keep the cords from accidentally getting pulled out, I put a zip tie around the end here and around just after where the connections are made, and cut it off, so that way if there's a tug on these wires, they won't go ripping off of the motor. Now I've cut a couple of pieces of. I took some strip aluminum and made a little angle bracket, sort of, with and drilled some holes for some screws to place through the plexiglass. I did the same thing with the other side, and I made it so that the wheels are about in the middle of these long parts here, so there would be some balance, and there's going to be some weight on the back once the batteries are there anyway, so I figured that would be alright. Now, a little bit about the components themselves. This uses the L298N motor controller, because I can't power, the motors can't take the load off of the Uno, off the Arduino Uno, so I needed something to run everything through and control the motors. So I'm using this standard little chip here, little board here rather. Now you'd be surprised how inexpensive these things are. I paid hardly any, like nothing, for this little machine that I've got here. I'm going to talk about. Again, so I understand it, and for my sake, I'm going to talk about the little terminals and component and pins here on the board. Over here in the front, this controls the 2 motors. I should start with the sides here. These 2 terminals and these 2 terminals on this side, the motor plugs into. Okay, and they have to be plugged in a certain way to make the motors rotate forward when pulses are sent to these. Now here we've got the power in the front. This is the ground in the middle. This over here is the 5 volt on the left of the ground, is the 5 volt input, and this is the 12 or output, and this is the 12 volt over here. Now over here next to that we have the pins, the controlling pins for this component. The ones on either end, those pins are called, they have jumpers on them right now. They're called the motor enables, and you can use those to vary speed by sending pulse width modulation signals to those. The longer the pulse, the longer the pulse itself, the faster the motor will go. So you can vary the speed. Now here we have inputs 1, 2, 3, and 4. I'll give you kind of a close-up of that if you can see it. 1, 2, 3, and 4. Right now the cords are coming out of them. 1 and 2 are for one motor, 3 and 4 are for the other motor. And you get the motors to move by sending through the software either a high or a low. And depending on what you send, it'll make the wheels turn or stop, or in reverse and stop. Now onto the Arduino. I have an Arduino. This is the Elegoo version of the, it's like an Arduino clone, but it works just as well. And over here on this top part here, these are all the digital pins. We've got 13, or 0 through 13, and down here these are the analog. We've got 0, 1, 2, 3, 4, and 5 analog inputs, and then we have up here the 5 volts, the 3.3 volts inputs, and the grounds. Okay. Now, what I did was off of 2 of the, and this is just, again, for my sake, just to remember what I did, I took the first 2 input pins. I'm not going to worry about speed with this robot, so I'm not using the enables, but I took the first 2 input pins on the motor controller and ran them up into pins, into inputs 9 and 8 on the digital pins section. And now, and by the way, if you see a little tilde next to a number when you're looking at one of these controllers, that means that it's capable of pulse width modulation. And you need to do that. If you're going to do speed control, you need to use one of those. 7 and 6 are paired up with 3 and 4 on the motor controller. Okay. And what we've got, the power sources, we've got a 5 volt red wire here going from the 5 volt terminal here over to the 5 volt on the Arduino, and then over here the black ground goes over to the ground on the Arduino. And then we have another black ground wire which is going to go to the power source, the main power source for the motors. This here will be the positive for the motor power source. Over here I just have a 9 volt battery. This is going to power the Arduino itself. Okay, and that has a jack on the end which will plug directly into the Arduino and handle the power for that. Now, I think that's all I can say about. That's just the basic setup to make the wheels turn, and I could actually program it right now and tell it to do basic things by itself. I can't control it yet. I'm going to add a component called the NRF24L01, which is the radio component that's going to send signals from a joystick, and then I can control it myself. But I could certainly put in a program right now into the Arduino that would make it move various places in the room, so on and so forth. So many seconds in one direction, turn so many seconds in another direction, which is kind of neat. And I'll show you the test program I'm going to use to power, just to do the test on the power on the motors to make sure that it works. And we will do that right now. Okay, here we have the program, or what's known as the sketch, for the Arduino to test my motors make sure that everything's going to work through the motor controller. And I don't have, this is the Blink program that's set up right now. I have a program here, the sketch, called Move Test, and I'll explain the lines here and show you what this is doing. The setup, I'm setting up the pins, or setting up the pins and the serial. The serial is an output that you can make comments in, like I have here, serial print line testing, and that will, on each iteration or of the program, on each iteration in the loop, the main loop of the program, it'll print testing to its serial, to its output. So what this is going to do is it's going to simply run the motors forward for 1 second and then pause with the motors stopped for 1 second, and then run them again for 1 second, and then stop them for 1 second and run them again for 1 second. And that's done with digital write, and I'm writing to pin 9, high, which is one of my motors is connected to pin 9, and high is just, I'm giving it a positive pulse there. It's going to run. You can give it a low to stop, which I have down here, digital write 9 low. And this function here, digital 7, digital write for 7, that's going to be for the other motor, making it go forward, and digital write to 7, it's going to stop it with low. And here's the delay. This is my 1 second delay, and 1 second delay here between each. And it's very, very simple. It's just so I can see, the wheels move, so I can see that everything's going to run through the motor controller. So I'll upload this to the Arduino and we will see if it works. Okay, so I've got my program all ready, and I have brought in a 6-volt battery, which will be my main power source for right now. I'm waiting. I've got a battery pack that's going to go on back here for 5 AA batteries, which will be just a little more power than I need, but I think it'll work. Going through here, it'll be 7.5 volts, and for now we're going to use the 6-volt battery to test the motors and to the main power lines, which will eventually go to the power source on the back here. I've attached little jumpers, and I'm going to hook those up to the these up to the 9-volt battery, and I'm going to plug the power source here into the Arduino. You can see all the lights come on, which is good. And you'll see right now on the Arduino itself there's a little light blinking there. That's the default program that's on the Arduino controller. It's called Blink, which, you know, for obvious reasons, it just makes a LED on the board blink on and off over and over again. And that's what I'm going to do now is I'm going to attach this USB cable to the Arduino and upload the program that I just wrote. And if everything is set and everything's connected correctly, we should see the motor fire up for a second and then stop and then go for a second and then stop, and we will see if that works. There we go. Hooking up the USB, and on the Arduino IDE, which you can't see, it's off camera, I'm going to press the upload button, and we'll see if it works right now. And as you can see, motors are running, and they are in fact running forward like I want them to. And everything seems to be working great. I'm going to re-upload Blink really quick. Stop all that from happening. There we go, and back it goes to blinking. Now, next, while I'm waiting for the power source, which should be here tomorrow or the next day, it's just it's impossible nowadays in the stores to get little hobbyists. You go to a hardware store, you just can't get little small electronics parts. You can buy huge, breakers and things like that for, wiring your house, but, there really isn't much in the way of hobbyist stuff. And the only hobby store in my town closed up shop a couple years ago, and now I would love to have one around, but we don't here in Albany. So I'm going to mess around with the next part of this, which will be setting up the remote connection. In this case, I'll be using a little controller called the NRF24L01, an adapter, and set up my little joystick and see if I can get this thing to move the motors using the joystick. Thanks for watching.